Good afternoon. This is Tatiana Math Resources, and we're looking at functions. Our objectives are: one, we're going to identify the four ways in which a relation can be represented: ordered pairs, mapping diagrams, graphically, and a table. Then I'm going to show examples of all four of these ways that a relation can be represented. Then I'm going to demonstrate how to draw a mapping diagram, and then 4, find the image of a number under a given function. Relation of functions, they can be written in 7 ways. 1, ordered pairs. 2, a table. 3, graph. 4, mapping. We have already seen relations represented as ordered pairs. I'm going to share that video in the description of this particular video. So ordered pairs, we have the example here. Ordered pairs in x and y. X and y coordinates. So this is our x, this is our y. X, and that's our y. Then it can also be represented in a table. You would notice that what is in the table is in the ordered pairs. So 3, 4, 3, 4. 7, 2, 7, 2. 0, negative 1, 0, negative 1. Graphically, so we're going to use the same order pairs from the previous slide, and then we're going to plot it on this Cartesian plane. So 3, 4. So we're going to go 3, the x value, 4. 7, 2. So if this is 6, here it would have to be 7. Let's just write that in. Okay. And we have 7, 2. Then we have 0, negative 1, 0, negative 1. Then we have negative 2, negative 2, 2. Negative 5, 0, 3, 3. So here the x value first, up, across, y value 3. Mapping diagram. Now to create a mapping diagram, you create 2 ovals with the domain on the left and the range on the right. Elements are not repeated. Connect elements of the domain with the corresponding elements in the range by drawing an arrow. You're going to see this soon. So we have these set pairs of these ordered pairs, or the coordinates, and we're going to put it into a mapping diagram. So you will notice we have our 2 ovals. On the left is our x, so let me just write that here. On the right is our y, and 2, negative 6. That's 2, and we go across with the arrow. Remember, we talk about drawing an arrow. So the connect elements of the domain with the corresponding elements in the range by drawing an arrow. So 2 goes to negative 6. 1, 4. We have 1. 1 goes to 4, as you can see here. 2, 4. 2 goes to 4. 0, 0, 0, 0. 1, negative 6. 1 goes to negative 6. And 3, 0. 3 goes to 0. Now, a function is a relation in which the members of the domain, the x values, remember that, do not repeat. So, for every x value, there is only one y value that corresponds to it. Y values can be repeated, so that's something you have to remember. Example, 2 the ordered pairs represent a function. So let's look at the first one. We have 4, 1. 5, 2, 8, 2, 9, 8. Now you would notice that 4, 5, 8, 9, all different. Remember, it says for every x, no, it says it here, you do not repeat the domain, the x values. So here we have 4, 5, 8, and 9. They're not repeated, but we can see that the y is being repeated in the 2. All right. So that means that it is a function. Yes, no x coordinate is repeated. All right, look at the second example. Here we have 3, 4, 7, 2, 0, -1, -2, 2, -5, 0, 3, 3. Now immediately I see 3 twice. Remember this rule? Do not repeat. The only thing I can repeat is the y. So this is not a function. No, 3 is repeated. 3 is repeated in the domain. Now, function notation, you can have it using letters such as F, G, H, and the likes. When we use f as a function, then for each x in the domain of f, f of x denotes the image of x under f. We're going to look at this, don't worry. The notation f of x is read as f of x. So here we have an example. Since the equation y equals to x minus 2 represents a function, we can also write it as f of x equals x minus 2. Find f of 4. Okay, so they want you to find what is 4 using this function x. F of x equals to x minus 2. So we're going to write back our function f of x equals x minus 2 and understand that we're substituting 4 wherever we see x. So we're going to write that as 4 minus 2. So remember, we replace the x with 4. So wherever we see 4 in the function, x in the function, we're going to replace it with 4. So there's an x here. We're going to replace it with 4. And 2 from 4 is equals to 2. So f of 4 is equals to 2. Here we have another example. F of x is equals to 5x minus 2. Find the value of 1, f of 2, 2, f of -3, part 3, f of 0. So let's work it out. So first one, f of 2. Now I like to write my thing over again. So f of x is equals to 5x minus 2. So f of 2 is equals to 5 by 2 minus 2. So that is 10 minus 2. That is 8. Number 2, I'm going to put 2 over here. F of -3 is equals, so we want to find f of, let me just make sure I write down right. So I want to say f, I need a space. So I'm just going to write f of x is equals to 5x minus 2. So f of 3, and it's a negative, is 5 by -3 minus 2. So that is -15 minus 2. So that's -17. Now let's change this and put it in a different color. -3. Because this is a big problem for students. Alright, so now we're going to do part 3. So f of x, we know is 5x minus 2. So f of 0 is 5. I'm going to put the 0 in a different color. So that is a 0 minus 2. So the answer is a minus 2. Okay, so our answers are, we can write it here. For this, it is 8. For this, it is -17. And for f of 0, we got out the answer -2. Now it's your turn. We have g of s is equals to 2s plus 3. Find g of -2. Looking forward to seeing your answers in the comment below. I hope this video was helpful. This is Tatiana from Tatiana Math Resources. We looked at functions. I hope the video was helpful. Don't forget to like, subscribe, share, leave a comment. Stay tuned for more.